Good morning. Today we are going to discuss the section Units and Measurement. 11th standard first chapter ആണ് സത്യം ഉള്ളത് പറഞ്ഞാൽ ഒരു ഇൻട്രൊഡക്ടറി ചാപ്റ്റർ ആണ് യൂണിറ്റ്സ് ആൻഡ് മെഷർമെന്റ്സ്. അതിനകത്ത് യൂണിറ്റ്സ്, ഡയമെൻഷൻസ്, ദെൻ സം ടെക്നിക്സ് ഓഫ് മെഷർമെന്റ്സ് ഇത്രയാണ് അത് കണ്ടെയ്ൻ ചെയ്തത്. അതിനകത്ത് അധികം പ്രോബ്ലമാറ്റിക് ക്വസ്റ്റ്യൻസോ ടഫായ സെക്ഷനോ ഒന്നുമില്ല. ഒരു ഇൻട്രൊഡക്ടറി ചാപ്റ്റർ ആയതുകൊണ്ട് മറ്റ് ചാപ്റ്റേഴ്സിനെ കമ്പയർ ചെയ്യുമ്പോൾ comparatively simple section. Okay, now let's move to the questions. Here we have 25 questions from the section of units and measurements. Now we are going to the first question. The first question is, which of the following is not a fundamental unit? I'll tell you something about the fundamental units. In SI system, 7 quantities are taken as the fundamental quantities: mass, length, time, electric current, temperature, luminous intensity, and amount of substance. And each one is having its own units also. Then the fundamental units are kilogram for mass, meter for length, second for time, then for current ampere, then for temperature Kelvin, luminous intensity from optics candela, then amount of substance mole. These 7 are the fundamental units of SI system. Here, the question is, which one is the fundamental unit? First one is A for ampere. Second one, K for Kelvin. Third one, candela. All these three, the A, B, and C choices are fundamental units. The last one is capital C, which represents coulomb. It's not a fundamental unit. Therefore, as far as the first question is concerned, A, B, and C are fundamental units. C, coulomb is not a fundamental unit. It's the SI unit of charge. Current into time equal to charge, and ampere second equal to coulomb. It's not the fundamental unit. Therefore, here, which one is not the fundamental unit? Here, the answer is coulomb. All the other three are fundamental unit. രണ്ടാമത്തെ ക്വസ്റ്റ്യനിലോട്ട് നമുക്ക് ഇനി പോവാം. The second question is, which of the following is used to represent charge? For charge, the SI unit is coulomb. And one more unit is there, 96,500 coulomb equal to 1 Faraday. Therefore, we have 2 units for charge, coulomb and Faraday. The SI unit is coulomb. Now, here the question is, which of the following is used to represent the charge? Actually, coulomb is the SI unit, but charge is the product of current and time. Therefore, coulomb equal to ampere second. Here, the choices are, first one, capital F. It is not Faraday. Capital F represents Farad. Farad is the SI unit of capacitance, not for charge. Second one is Faraday. It is a unit for charge. I have already told 96,500 coulomb equal to 1 Faraday. Therefore, here Faraday represents the unit of charge. Then third choice, A, yes, A stands for ampere, smallest for second. Ampere second means coulomb itself. It also represents a charge. Therefore, here the answer is Faraday and ampere second. Instead of coulomb, here we have written ampere second. Therefore, the correct answer is D. That is B and C are correct. അതായത് Faraday, ampere second. ഇത് രണ്ടും ചാർജിനെ റെപ്രസെന്റ് ചെയ്യുന്ന യൂണിറ്റ് ആണ്. For the second question, the answer is, the correct choice is D. Now, let's go to the next question. Let's move to the third question. The question is, which of the following is the correct representation of a unit used for energy? First, I will tell you about different units of energy. Different units for energy are joule, erg, electron volt, and calorie. Joule is the SI unit of energy or work. CGS unit is erg, and we have 10 raised to 7 erg equal to 1 joule. Similarly, 1 calorie means 4.2 joule. 4.2 joule equal to 1 calorie. 1 calorie. Similarly, 1 electron volt equal to 1.6 into 10 raised to minus 19 joule. 1 electron volt representation is small e capital V equal to 1.6 into 10 raised to minus 19 joule. You should know the conversion factor to SI system. Therefore, I'll tell you once again, different units of energy are joule, erg, electron volt, and calorie. Joule is the SI unit, erg is the CGS unit. Here, 10 raised to 7 erg equal to 1 joule. The conversion factor is 10 raised to 7. Similarly, 4.2 joule equal to 1 calorie. Then 1 electron volt equal to 1.6 into 10 raised to minus 19 joule. 1 calorie means 4.2 joule, and it is the heat required to raise the temperature of unit mass of water through 1 Kelvin. Similarly, 1 electron volt is the energy acquired by an electron when it is accelerated through a potential difference of 1 volt. Its value is 1.6 into 10 raised to minus 19 joule. Here, the question is, which of the following is the correct representation of a unit used for energy? Here the answer is joule, but we can represent joule or any unit in different pattern. But there are some important conditions for the unit representations. First one is, if a unit comes from the name of a scientist, we can use the first capital letter only. Therefore, for joule, here we can write either a capital J, or if you want to write the complete term, start with the small letter and plural with S should not be used. The conditions I will repeat once again. If a unit comes from the name of a scientist, the first capital letter is enough. Otherwise, the first small letter is enough. Example, for meter, smaller is enough. Second, smallest is enough. Then, to write the complete term, start with the small letter. Here, I started with a small j, Joule. Start with small letter j itself. Then, plural with s should not be used. Joules is wrong. Similarly, meters, wrong. Seconds, wrong. Minutes, wrong. If it is written as minutes, it means minute second. Last S again stands for second. S is the unit representation of second. Therefore, here, the correct representation of joule is capital J in the given question. Therefore, the correct answer is A. Next question is about the dimensional formula. In dimensional analysis, we have 5 fundamental quantities: mass, length, time, electric current, and temperature. And we can represent all the other quantities in powers of these 5 fundamentals. That's called dimensional formula. Dimensions of a physical quantity are the powers to which the fundamentals are to be raised. That's all the existing quantities can be written in powers of these 5 fundamentals. Here the question is the dimensional formula of electric potential, means voltage. Basically, potential is the work required in bringing a unit positive charge from infinity to the present position. In short, potential is the work divided by electric charge. Potential is the work required in bringing a unit positive charge from infinity to the present position. Mathematically, work by charge equal to V. Work divided by charge. Then to get the dimensional formula, first we have to write the dimensions of work, then divide it by that of charge, then we will get the dimensional formula of electric potential. I'll write it here. Work M L square T raised to minus 2. Dimensional formula of work divided by charge. T I. Charge is current into time. I represents the current. You can write I or A. One representation for a quantity. T into I. Current into time gives charge. Therefore, the dimensional formula of charge is Ti. Now, we get the result M L square T raised to minus 3 I raised to minus 1. That is the electric potential has the dimensional formula M L square T raised to minus 3 I raised to minus 1. Therefore, for the given question, the correct choice is B. That is ml square T raised to minus 3 I raised to minus 1.
റിപ്പീറ്റ് ചെയ്തിട്ട് ടിക്കറ്റ്
Here, the dimensional formula of electric potential is ml square T raised to minus 3 I raised to minus 1. That is here. ml square T raised to minus 3 I raised to minus 1. That is B choice is the correct answer for the dimensional formula of electric potential. Okay. Now we are going to the next question. The question is magnetic flux can be represented by the unit. In the chapter units and dimensions. അത് ഉൾപ്പെടുത്തിയതിന്റെ ഉദ്ദേശം എന്ന് പറയുന്നത് തന്നെ ലോകത്തിലെ എക്സിസ്റ്റിംഗ് ക്വാണ്ടിറ്റീസിന്റെ എല്ലാ യൂണിറ്റ് നിങ്ങൾ തറവ് ആയിരിക്കണം എന്നുള്ളതാണ്. അല്ലാതെ വെലോസിറ്റി, ആക്സലറേഷൻ, ഫോഴ്സ്, മാസ്, വർക്ക് മാത്രമല്ല, നിലവിലുള്ള എക്സിസ്റ്റിംഗ് ക്വാണ്ടിറ്റീസിന്റെ എല്ലാ യൂണിറ്റ് തലക്കകത്താക്കാൻ നമ്മൾ ശ്രമിക്കണം. അതാണ് ഈ യൂണിറ്റ്സ് ആൻഡ് ഡയമെൻഷൻസ് എന്നൊരു ചാപ്റ്റർ ഇൻക്ലൂഡ് ചെയ്യാനുള്ള റീസൺ അതാണ്. But here the unit is magnet. Here the question is about magnetic flux. Magnetic field intensity can be represented in different ways. Magnetic flux means collection of magnetic lines of force. And flux will be expressed in Weber. Weber is the SI unit of magnetic flux. Another one more unit is there. The other unit is Maxwell. Maxwell and Weber are the units of magnetic flux. Weber is the SI unit. But the magnetic field intensity or strength of a magnetic field or magnetic flux density can be expressed in Gauss and Tesla or Weber per meter square. Tesla is the unit of magnetic flux density or magnetic induction, and field strength can also be expressed in terms of this Tesla. Then Gauss is the smaller unit. Equivalent to Sages. It is the smaller unit, not SI unit. Gauss and Tesla are the units of magnetic flux density. I'll write the units. Then, here the question is about magnetic flux. Magnetic flux has the unit Maxwell. Magnetic flux can be represented in Maxwell. Similarly, SI unit Weber. Then, Gauss is for magnetic flux density. Therefore, here the correct answer is A and B, D choice. D choice is the correct answer. Maxwell and Weber are the units of magnetic flux. The SI unit is Weber, but these two are used to represent magnetic flux. Here the correct answer is D. A and B are correct. Okay. Next question is about the scales of temperature. Different units of temperature are 1 degree Celsius or degree centigrade. Another one, Kelvin or degree absolute. Both are same. Absolute scale reading and Kelvin. Another one, Fahrenheit scale. Human body temperature, Fahrenheit. Then one more is there, degree Roman, another unit. 4 different units are, first one, degree Celsius. Then Kelvin or degree absolute. Here, ഒരു കാര്യം പ്രത്യേകം ശ്രദ്ധിക്കണം, കെൽവിന്റെ കൂടെ ഡിഗ്രി സൈൻ ഷുഡ് നോട്ട് ബി യൂസ്ഡ്. ഡിഗ്രി സൈൻ യൂസ് ചെയ്യണമെന്ന് നിർബന്ധ ബുദ്ധിയുള്ളവരാണെങ്കിൽ ഡിഗ്രി ആബ്സല്യൂട്ടിനെ എഴുതാവും. സെയിം റീഡിംഗ് ആണ്, ബട്ട് റെപ്രസെന്റേഷനിൽ ഡിഗ്രി സൈൻ ഷുഡ് നോട്ട് ബി ഹിയർ. Now, third one is degree Fahrenheit. Then last one, degree Romer. Degree Romer spelling is Raumur. Different units are degree Celsius or degree centigrade, Kelvin or degree absolute, then degree Fahrenheit, and last one, degree Roman. In Celsius scale, the ice point is 0 and the steam point is 100. Similarly, in Fahrenheit scale, the ice point is 32 and the steam point is 212. That is 180 intervals are there instead of 100 intervals in centigrade scale. Now, in Roman scale, this ice point is 0 and the steam point is 80. Only 80 divisions are there. Here, some connections are also there. Connecting Celsius scale and Fahrenheit scale, we have a formula F minus 32 by 180 equal to C by 100, or cross multiplying 9 by 180 by 100, 9 by 5 C plus 32 equal to Fahrenheit. Yeah. Therefore, we can convert from one system of unit to another one. 9 by 5 C plus 32 equal to Fahrenheit. Now, about Roma scale, ice point is 0 and steam point is 80, and the relationship is C by 5 is equal to R by 4. These are the relationships. F minus 32 by 180 equals C by 100 for connecting Fahrenheit scale reading and the Celsius scale reading. Then C by 5 equal to R by 4, connecting Celsius scale and Roman scale. Similarly, 273 plus Celsius reading will give the Kelvin. C plus 273 gives the Kelvin value. These are the connecting formulae. Now, here the question is coincide. Fahrenheit scale and the Celsius scale coincide at dash. Means if two thermometers are dipped under a particular circumstance, both will give the same reading. Similar here for Celsius scale and Fahrenheit scale, that coinciding point is minus 40. That is, at the temperature of minus 40 degrees Celsius, Fahrenheit scale will also give the same reading, minus 40. We can solve that value also. How it can be obtained? Let us check. F minus 32 by 180 equal to C by 100. If both the measuring scales gives the same reading, we can use the same variable for both the letters. Instead of C, we can write X. Similarly, instead of F, we can write X. Here and here, we put X. Then solving, we will get the value of X as minus 40. That is, the Celsius scale and the Fahrenheit scale coincide at minus 40. Similarly, Kelvin scale and Fahrenheit scale should also coincide at a particular temperature, that's 574.25. At the temperature of 574.25, both the Kelvin scale and the Fahrenheit scale coincide. Similarly, Roman scale and Celsius scale can coincide at 0 because C by 5 equal to R by 4 at 0, both will coincide. Now, here the answer is the coinciding point of Celsius scale and Fahrenheit scale, that is minus 40. Therefore, for the given question, the correct choice is D, minus 40. That is, D choice is the correct answer. Minus 40 is the coinciding reading. Okay. Next two questions are about the dimensional formula again. We have already mentioned that dimensions of a physical quantity are the powers to which the fundamentals are to be reached. First one is about Stefan's constant. I will explain the Stefan's law first. The energy radiated from unit area in unit time. Energy per unit area in unit time. Energy divided by area divided by time. This is called radiant emittance. According to Stefan's law, radiant emittance of a or emissive power of a, both are same, radiant emittance or emissive power of a perfectly black body will be proportional to the fourth power of the absolute temperature. That is, gradient emittance of a perfectly black body equal to a constant sigma into T raised to 4. Gradient emittance of a perfectly black body will be proportional to the fourth power of the absolute temperature equal to sigma T raised to 4. Sigma is called Stefan's constant. Its value is 5.67 into 10 raised to minus 8. Sigma is called Stefan's constant, 5.667 into 10 raised to minus 8 watt per meter square per Kelvin raised to 4, or 5.67 into 10 raised to minus 8 SI unit. അത് ഓർത്തിരിക്കാൻ എളുപ്പമാണ്. 5, 6, 7, 8 അടുത്തടുത്ത 4 നമ്പറാണ്. 5.67 into 10 raised to minus 8 SI unit. The sigma is called Stefan's constant. Here, the question is the dimensional formula of Stefan's constant. Look here. Sigma equal to energy divided by area divided by time divided by T raised to 4. Or comes at the denominator side. Then energy per unitary unit divided by temperature raised to 4. Now, the dimensional formula is for energy ml square T raised to minus 2. Then for area L square. Then for time capital T. Then for temperature K or theta raised to 4. Therefore, here the answer is M, L square and L square cancels. T raised to minus 3, K raised to minus 4. The dimensional formula of Stefan's constant is M T raised to minus 3, K raised to minus 4. Here, the answer is A. M T raised to minus 3, K raised to minus 4. This is the dimensional formula of Stefan's constant. Here the question is, dimensional formula for the following 3 questions. First one, Stefan's constant, M T raised to minus 3, K raised to minus 4. A choice is the correct answer. Next question is the dimensional formula of specific heat capacity. 3 questions are from the dimensional analysis. First one, already over Stefan's constant. Next one, specific heat capacity. Specific heat is the heat required to raise the temperature of unit mass of a substance through 1 Kelvin. Then the mathematical expression comes like heat required to raise the temperature of unit mass. Therefore, heat divided by mass per degree rise of temperature at the denominator. Rise of temperature. Heat divided by mass divided by rise of temperature. For heat, the dimensional formula is M L square T raised to minus 2. Heat is a form of energy. Therefore, the dimensional formula of heat will be equal to dimensions of energy divided by mass divided by rise of temperature. Here, I am taking K for temperature. K or theta can be used. Now, simplifying the dimensional formula of specific heat capacity becomes M cancels, then L square T raised to minus 2 K raised to minus 1. This is the dimensional formula of specific heat. L square T raised to minus 2 K raised to minus 1. B choice is the dimensional formula of specific heat capacity. Again, one more question from the dimensional analysis. Dimensional formula of electrical conductivity. According to Ohm's law, V equal to IR. Then R is called resistance, the proportionality constant. And resistance of a conductor will be proportional to the length of the conductor and inversely proportional to the cross-sectional area. That is, R proportional to the length of the conductor and inversely proportional to the cross-sectional area. Therefore, R equal to rho L by A. This proportionality constant rho is called specific resistance or resistivity. And 1 by resistivity equal to, I'm using sigma for this symbol, 1 by rho equal to sigma. 1 by resistivity gives the conductivity or specific conductance. Here, the question is the dimensional formula of electrical conductivity. First, rho equal to RA by L. RA by L. Similarly, sigma equal to 1 by rho means reciprocal. Sigma equal to L by RA. L is the length, R is the resistance, A is the area. Now taking the dimensions of each term in the given equation, instead of length, capital L, instead of resistance, voltage by current gives resistance. Its dimensional formula is M L square T raised to minus 3 I raised to minus 2. For electric potential, we have already mentioned ML square T raised to minus 3 I raised to minus 1. Potential divided by voltage divided by current gives the resistance. Therefore, it becomes ML square T raised to minus 3 I raised to minus 2. Then for area, L square. Simplify, M raised to minus 1, L raised to minus 3, L raised to 4, another L at the top, then L raised to 3 at the bottom, therefore L raised to minus 3, then T raised to 3, I raised to 2. L square, L raised to 4, then L raised to 3 at the denominator, L raised to minus 3 at the numerator, M raised to minus 1, L raised to minus 3, T raised to 3, I raised to 2. This is the dimensional formula of electrical conductivity. Therefore, here the answer is M raised to minus 1, L raised to minus 3, T raised to 3, I raised to 2. A choice is the correct answer. Therefore, the dimensional formula of electrical conductivity is M raised to minus 1, L raised to minus 3, T raised to 3, I raised to 2. That is A choice. The next question is also about the dimensional formula. Here, according to the principle of homogeneity of dimensions, each term of an equation should have the same dimensional formula. ഒരു ഇക്വേഷനിലെ ഓരോ ടേമിനും ഒരേ dimensional formula ആയിരിക്കണം. That's called principle of homogeneity. Here, the given data is thermo EMF. After all, it's an EMF, potential, voltage. Thermo EMF equal to V equal to AT plus BT square. Then left side term V, then right side terms AT and BT square. All the three terms should have the dimensions of voltage or electric potential. Here, the question is, thermo EMF is given by AT plus BT square. A and B are called thermoelectric constants and their dimensional formulae are. Let's take it. For electric potential, we have already mentioned M L square T raised to minus 3 I raised to minus 1. This should be the dimensional formula of AT and BT square. Therefore, for A, the dimensional formula is the dimensions of V divided by dimensions of T. In the in the given equation, V equal to AT plus BT square. Here, A and B are thermoelectric constants. In association with A T is there, and associated with BT square is there. That is, all the three terms should have the dimensions of voltage. Now, dimensions of A means dimensions of voltage divided by temperature. That is K. Then it becomes A. Dimensions of voltage is given M L square T raised to minus 3 I raised to minus 1. divided by a temperature K. Then ml square T raised to minus 3, I raised to minus 1, K raised to minus 1. Then for the next term, Vt square should have the dimensions of voltage. That is, voltage ml square T raised to minus 3, I raised to minus 1 divided by T square, K square. Then ml square T raised to minus 3, I raised to minus 1, K raised to minus 2. That is, B choice is the correct answer. ml square T raised to minus 3, I raised to minus 1, K raised to minus 2. B choice is the correct answer for the thermoelectric constants A and B. Next question is about the simple pendulum. The time period of oscillation of a simple pendulum is T equals 2 pi root of L by G. Root of L by G. L is the length of the pendulum. G, acceleration due to gravity. Capital T, time period. This formula can be derived by dimensional method also. Therefore, here, root of L by G will have the dimensions of time. Here, 2 pi is a dimensionless constant. T equal to 2 pi root of L by G. Root of L by G will have the dimension of time, means the proportionality constant 2 pi is dimensionless. Therefore, here the answer is D. That is, the proportionality dimensional formula of the proportionality constant is dimensionless. It has no dimensions. We'll go to next question. Next question is about the unit. Here the question is, Henry is the unit of. Actually, Henry is the SI unit of self-inductance or mutual inductance, generally inductance. Total flux will be proportional to the current. Flux is equal to a constant L into I. Then L is called coefficient of self-induction or self-inductance. Total flux, I'll write it as N phi, proportional to the current flowing, then N phi equal to Li. This proportionality constant is called self-inductance or coefficient of self-induction. That is, to find the dimensional formula of L, N phi divided by I. N phi, the total flux per unit current, gives self-inductance. Here, Henry is the SI unit of self-inductance and for mutual inductance. Therefore, the correct answer is inductance. C choice is the correct answer. Henry is the SI unit of inductance. Next question. Next question is, which of the following is the unit of illuminance? Illuminance is actually representing brightness. SI unit of illuminance is lux, Lux, lux. Total amount of light coming from a source in unit time is called luminous flux. It can be expressed in lumen. Luminous flux per unit solid angle is called candela. Luminous intensity, its SI unit is candela. Then luminous flux per unit area gives the illuminance. It varies with the distance. Its SI unit of illuminance is Lux, lux. Then one more unit is there, 10 raised to 4 lux equal to 1 volt, PHOT. It is a larger unit. Therefore, for illuminance, we have two units, lux and volt. SI unit is lux or lumen per meter square. Here, the choices are, first one, volt, it is used to represent illuminance. Second one, lux, it is the SI unit of illuminance. Third one, candela, that is lumen per steradian. It is the unit of luminous intensity. Therefore, the answer is D. A and B are correct. A is volt, B is lux. Therefore, A and B are correct. That's the answer is D. Next question is also about the unit. Fermi and angstrom are given by one. Fermi means 10 raised to minus 15 meter or femtometer. Then angstrom means 10 raised to minus 10 meter. Both the units are used to represent lengths. Here the question is Fermi and angstrom are given by, answer is 10 raised to minus 8 meter and 10 raised to minus 10 meter. That's it. So it is correct. First choice is 10 raised to minus 8 meter and 10 raised to minus 10 meter. It is wrong. One Fermi means 10 raised to minus 15 meter. B choice is 10 raised to minus 15 meter and 10 raised to minus 10 meter. That's the correct answer. One angstrom equal to 10 raised to minus 10 meter. One Fermi equal to 10 raised to minus 15 meter. Here, the correct answer is B choice. 10 raised to minus 15 meter and 10 raised to minus 10 meter. One Fermi, one angstrom. Therefore, the answer is B. Next one is a direct question. One electron volt equal to dash. In our earlier discussion, we have already mentioned the meaning of electron volt and its value. Once again, I will repeat. Electron volt is the unit of energy. Then electron volt is the energy acquired by an electron when it is accelerated through a potential difference of 1 volt. And 1 eV equal to 1.6 into 10 raised to minus 19 joule. Here the conversion factor is asked here. Now, for the question, the correct choice is 1.6 into 10 raised to minus 19 joule. That is B choice is the correct answer. Next question is also about the units. Which of the following is not a unit of length? Choices are parsec, second one angstrom, third one AU means astronomical unit, fourth one small d capital B represents decibel. I will tell you about each and every. First one is parsec. It is actually the largest unit of length. 3.2 light year is the value of 1 parsec. Light year means the distance traveled by a light ray in 1 year. And 3.2 light year equal to 1 parsec. Therefore, parsec is the unit of length. Second one, angstrom. 10 raised to minus 10 meter. Very small length to represent wavelength and something. Then, third one, AU, astronomical unit, average distance of sun from the earth. That's astronomical unit. Last one, dB. Decibel is used to represent the sound intensity or the level of sound. Then the choices A, B, and C represent length. Last one represents sound intensity. Therefore, here the answer is decibel. D choice is the answer. Next question is, which of the following are having the same unit? Choices are, I will read one by one. Choices are resistance and impedance, conductance and admittance, conductance and conductivity. Resistance and impedance. In a DC circuit, voltage by current will give resistance V by I equal to R by Ohm's law. But in an AC supply, the net circuit voltage divided by current, circuit current will give the impedance of the circuit. Impedance means it will have the influence of resistance, inductor, and capacitor. The net resistive effect of the entire circuit in an AC supply is mentioned as impedance. Therefore, here resistance and impedance will have the same unit O. Resistance in a DC circuit, voltage by current equal to resistance. In an AC circuit, voltage by circuit current equal to impedance. It is also expressed in Ohm. Second choice is conductance and admittance. 1 by resistance gives conductance. Similarly, reciprocal of impedance. 1 by impedance gives admittance. Therefore, conductance and admittance will have the same unit, ohm raised to minus 1 or mho or Siemens. For conductance, ohm raised to -1, it can be written as mho or Siemens. Similarly, for admittance also, 1 by impedance equal to admittance with the same unit, ohm raised to -1, mho or Siemens. Therefore, here the answer is, question is following are having the same unit. A choice is correct. Resistance and impedance, same unit. B choice is also correct. Conductance and admittance. C choice, conductance and conductivity. Conductivity will have different units. Therefore, here the correct choice is D. Both A and B are correct. A and B are correct. Therefore, D choice is the correct answer. Next question is about the pressure. Pressure means thrust by area. Normally acting force is called thrust. Normal force per unit area or thrust per unit area gives the pressure. Therefore, the SI unit of pressure is normal force by area gives the pressure. Normal force is called thrust. Therefore, we can write thrust by area. Both thrust and force will have the same unit. Therefore, the SI unit of pressure is Newton per meter square. That is represented as Pascal, capital P, small a for Pascal, PASCAL. SI unit of pressure is Pascal. CGS unit is dyne per centimeter square. Some other units are also there. Atmosphere, bar, torr, etc. Bar means 10 raised to 5 Pascal. 1 atmosphere means 1.013 into 10 raised to 5 Pascal. Torr means pressure exerted by 1 millimeter column of mercury. Therefore, different units of pressure are Pascal, dyne per centimeter square, bar, torr, and atmosphere. Here, the question is, which one is not the unit of pressure? First one is PA, it is the unit for pressure. Second one, bar, it is also used for pressure. Third one, dyne per centimeter square, it is the CGS unit of pressure. Fourth one is poise. Poise is the CGS unit of viscosity, not for pressure. Therefore, here the correct answer is poise, which is not the unit of pressure. Poise is not the unit of pressure. All the others are used to represent pressure. The answer is D. Next question. Which one is dimensionless, not having a dimension? Choice 1, Planck's constant. Planck's constant containing equation is E equal to h nu. Nu is the frequency, E is the energy, H is Planck's constant, its value 6.625 into 10 raised to minus 34 joule second. It has unit, joule second. Nu is frequency. Anyway, Planck's constant has both the unit and dimensions. Its SI unit is joule second. Second choice is gravitational constant, the capital G. The containing equation is F equal to G m1 m2 divided by r square. Here, capital G represents the gravitational constant. It's a universal constant. Its value is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. It has also both dimensions and units. Next choice is Stefan's constant. We have already mentioned Stefan's law. The radiant emittance of a perfectly black body is proportional to the fourth power of the absolute temperature. And Stefan's constant is also having dimensional unit. The next one, Reynolds number of viscosity. By Reynolds law, the in viscosity, the limiting velocity above which the streamline motion is stopped and the turbulence starts. That limiting velocity is called critical velocity. And that critical velocity is given by Vc equals n eta by rho r. where rho is the density of the fluid, r is the radius of the tube through which the liquid flows, eta is the coefficient of viscosity, Vc represents the critical velocity. Here, eta by rho r will have the dimensions of velocity. Therefore, this capital M, the proportionality constant of Reynolds law, that's called Reynolds number, it is dimensionless. Therefore, here the question is which one is dimensionless? Therefore, the answer is Reynolds number of viscosity. It is a dimensionless constant. Therefore, the correct answer is D. Next one is a small question. 1 picofarad equal to dash farad. If the multiplying factor is 10 raised to minus 3, it is milli, minus 6, micro, minus 9, nano, minus 12, pico. Here, the question is 1 picofarad equal to dash farad. That is 10 raised to minus 12 farad equal 10 raised to minus 12 farad equal to 1 picofarad. Therefore, here the answer is 10 raised to minus 12. That is a choice. The conversion factor is 10 raised to minus 12. Similarly, the positive side also, if the multiplying factor is 10 raised to 3, we will represent it by kilo. Then 10 raised to 6, mega, 10 raised to 9, giga, 10 raised to 12, teta. In the positive side, kilo, mega, giga, teta. Similarly, the negative side, milli, micro, nano, pico. Here, for pico, the conversion factor is 10 raised to minus 12. The correct answer is A. Next question is about the multiplying factor. The multiplying factor is 10 raised to minus 18. The prefix will be dash. First choice is femto. It is 10 raised to minus 15. 10 raised to minus 15 meter means femtometer. Similarly, second choice is ATTU, 10 raised to minus 18. Here the question is, if the multiplying factor is 10 raised to minus 18, the prefix will be dash. It is ATTU. Therefore, the correct choice is B. ATTU represents 10 raised to minus 18. Next question is about the magnetic field. Magnetic field intensity cannot be expressed in. Choices are Gauss, Easton, Tesla, and Weber. I'll discuss one by one. Gauss is the smaller unit of magnetic flux density or magnetic induction. Easton is also used to represent the intensity of magnetic field. OER-STED. It is used to represent the strength of magnetic field. SI unit of the magnetic field strength or magnetic flux density or magnetic induction is Tesla or Weber per meter squared. Now, here the D choice is Weber. Weber is the SI unit of magnetic flux. Now, the question is, the field intensity cannot be expressed in. It can be expressed in Gauss, it can be expressed in Easton, it can be expressed in Tesla, but cannot be expressed in terms of Weber. Therefore, the correct answer is D choice. Weber is used to represent magnetic flux, known for magnetic flux density. Hence, the answer is Weber. Odd one is Weber. Next question is, poise is the unit of. In the earlier discussion, we mentioned the name poise. It is the CGS unit of viscosity. Here, some other choices are also given. Poise is the unit of dash. First choice is pressure. For pressure, the SI unit is Pascal and CGS unit is dyne per centimeter square. B choice is surface tension. For surface tension equal to force by length, Newton per meter. Then, third choice is viscosity. Poise is the CGS unit of viscosity. Its SI unit is Newton second per meter square. Then, elasticity, it is not a quantity, it's a property. Therefore, poise is the unit of dash, means poise is the unit of viscosity and it is the CGS unit of viscosity. Therefore, here the correct answer is C. Poise is the unit of viscosity. Next one is dimensional formula of Planck's constant. Choices are A, dimensions, dimensionless. No, it has dimensions. I'll write the corresponding equation. According to Planck's quantum theory, energy is emitted or absorbed in the form of discrete packets called quanta, whose smallest unit is a photon. The energy of the photon is proportional to its frequency. That is E is equal to h nu by Planck's quantum theory. H is called Planck's constant. To find the dimensional formula, first we have to convert the equation as h equal to E by nu. E is the energy, nu is the frequency. Dimensional formula of energy is m L square T raised to minus 2 divided by T raised to minus 2 divided by dimensions of frequency 1 by time period T raised to minus 1. Simplifying m L square T raised to minus 2 is there already plus 1 then T raised to minus 1. Then dimensional formula of Planck's constant is mL square T raised to minus 1. That is B choice is the correct answer. Here, the last question is, which of the following are having the same dimensional formula? First choice is energy density and pressure. First, you should know the meaning of these terms. Energy density means energy per unit volume. Electron density means number of electrons flowing per unit volume. Charge density means charge per unit area. Linear density means mass by length. Linear density of charge means charge per unit length. Similarly, different terms are having different meaning. Okay, energy density, energy by volume. Then pressure, normal force by area. Therefore, energy by volume and normal force called thrust by area will have the same dimensional formula. Here, the correct answer is A. Which of the following are having the same dimensional formula? Once again, I will explain. Energy density means energy by volume. Energy by volume. Energy by volume. Similarly, അതിന്റെ കൂടെയുള്ളത് pressure. Pressure is normal force by area. Normal force by area. Energy by volume and normal force by area will have the same dimensional formula. Therefore, the first choice is the correct answer. Here is the answer. Today, we have discussed 25 questions from the first units, from first chapter, units, dimensions, and measurements. That's the introductory chapter of the 11th standard. Very simple chapter actually compared to the following chapters. വളരെ simple ആയി പക്ഷേ എന്നാലും ചോയ്സസ് മേ ബി കൺഫ്യൂസിങ് ആസ് ഫാർ ആസ് MCQ are concerned. മൾട്ടിപ്പിൾ ചോയ്സ് ഓബ്ജക്റ്റീവ് ടൈപ്പ് ക്വസ്റ്റ്യൻസിൽ ചോയ്സ് എപ്പോഴും എല്ലാ ചോയ്സും റീഡ് ചെയ്ത് അനലൈസ് ചെയ്തതിന് ശേഷമേ ആൻസർ പറയാം. ഇതൊരു സിമ്പിൾ ചാപ്റ്റർ ആണ്. 25 ക്വസ്റ്റ്യൻസിന് എല്ലാ ചോയ്സസിനെ കുറിച്ചും ഡീറ്റെയിൽ ആയി നമ്മൾ ഡിസ്കസ് ചെയ്തു. ഇനി നിങ്ങൾ ചെയ്യേണ്ടത് ഈ ഡിസ്കഷന് ശേഷം ആദ്യം കെയർഫുൾ ആയിട്ട് 100% കോൺസെൻട്രേഷനോടുകൂടി ഡിസ്കഷൻ അറ്റൻഡ് ചെയ്യുക. അത് കഴിഞ്ഞതിന് ശേഷം പേപ്പറും പെന്നും എടുത്തിട്ട് ഒരു റൗണ്ട് ജസ്റ്റ് ലൈക്ക് എ ടെസ്റ്റ് പേപ്പർ റൈറ്റ് ഫ്രം ദി ബിഗിനിങ് ടു ദി 25th ക്വസ്റ്റ്യൻ നിങ്ങളൊന്ന് എഴുതി വർക്ക്ഔട്ട് ചെയ്ത് നോക്കിയാൽ അത് തലക്കകത്ത് റെക്കോർഡഡ് ആയിരിക്കും. എൻ്റെ ഒരു പേഴ്സണൽ റിക്വസ്റ്റ് ആണ്. അത്രയും കൂടെ നിങ്ങൾ ചെയ്താൽ അത് പെർമനന്റ് ആയിട്ട് സ്റ്റോർ ചെയ്ത് ഈക്വലന്റ് ആണ്. ഏതായാലും യൂണിറ്റ്സ് ആൻഡ് മെഷർമെന്റ്സ് എന്നുള്ള ചാപ്റ്ററിലെ 25 ക്വസ്റ്റ്യൻസ് നമ്മൾ ഡിസ്കസ് ചെയ്ത് കഴിഞ്ഞു. ഇത് പറഞ്ഞ ഇൻസ്ട്രക്ഷൻസ്, ഇതിന്റെ ഫോളോ അപ്പ് ആക്ഷൻസ് ഇതുപോലെ വീട്ടിൽ നിന്ന് ഒന്നുകൂടെ എല്ലാ പേപ്പറും പെന്നും എടുത്ത് പ്രാക്ടീസ് ചെയ്യുന്നു വിശ്വസിക്കുന്നു. വിഷ് യു ഓൾ ദി ബെസ്റ്റ്. താങ്ക് യു.